Yeah.
Okay. So, uh, as we have learned about turbine, in the turbine we get the work, but in compressor, we give the work. Okay. In refrigerator also, in refrigerator, heat pump also, we give the energy input to the refrigerator. Okay. So that will be your work transfer. Okay. That will be your work transfer, and this work transfer does not happen due to temperature change. Okay. if there is temperature change, yeah, or temperature difference between the two devices, then there will be only one energy transfer, that is heat transfer. Okay. So I hope you have learned about energy transfer. Okay. Now we will move about energy transformation. What is energy transformation? So let's start about energy transformation. In the thermodynamics, we study about energy transfer and also energy transformation. Okay. As the name suggests, energy from the energy transformation, you can easily call here the energy is transformed. Here the energy is transformed from one form to another form. As you have learned through the conservation of energy principle. Conservation of energy principle basically says that energy can neither be created nor be destroyed. It can only be transformed into one form to another form. Okay.
Yeah.
So let's start about the basic concept about energy transformation. Some basic concept, and after that I will give you technical example of energy transformation. Okay. So here let us assume this is your ground. Let us assume this is our ground. And here this is the roof of our home. Okay. And at the roof there is a balloon. Filled with some heavier gas. Okay. There is a balloon which is filled by heavier gas. If there is lighter gas, then balloon will go upside. Okay.
Yeah.
So we fill this balloon by the heavier substance. Okay. Now since the balloon is at a higher level to the ground, this means this balloon has a higher potential energy. What is potential energy? Now, potential energy, I will give some basic concept of this potential energy. Okay. Potential energy. Now understand what is potential energy. If a body is displaced from its mean position by some distance, then this means that body has attained some potential energy. Okay. Now as we have seen that this balloon is at, let us assume, h distance from the ground. This distance is h.
Yeah.
So we can easily tell that this balloon has displaced from the mean position by h distance. That means this body has higher potential energy. Anywhere if you see the body has displaced from the mean position, okay, from the mean position, or we can call reference position. So this ground is our reference position. the balloon is displaced from the reference position by h meter. Okay, this means it has some potential energy, and we can call this maximum potential energy. So this balloon at this position has maximum potential energy. Let us assume this potential energy is of 20 joule. Let us assume this balloon has 20 joule potential energy at this position. Okay. Now tell me, what is the kinetic energy of this body at this position?
Yeah, so potential energy.
Kinetic energy. What is the
kinetic energy? Yeah, zero. Yeah.
No, kinetic energy. Kinetic energy is basically associated with the moving object. If body is moving, then kinetic energy comes. But here balloon.
Yeah, but it's stationary.
Okay. Here body is stationary, so it is not moving. It does not have a velocity, so kinetic energy of this body at this position will be zero. Okay.
Yeah.
So kinetic energy at this position is a zero. Now, if we drop this balloon to the ground, if this balloon is dropped, now what happened? Now let us assume at any time body is at this position. Let us assume this balloon as this is at this position after some time, since body is falling. Okay. Now let us assume at any time this body is at this position. Now tell me, the distance from the ground is less as compared to the initial distance. This distance is, let us assume, y. You can see that y is less than h. When distance is large, the formula for potential energy is mgh. mgh. H, what is h? H is the distance.
Height, yeah.
Height, okay. And what is m? Mass of the body. Okay.
Mass, yeah.
But here the distance is less, so you can tell that this body is having lesser potential energy at this position. This body is having less potential energy at this position because height is less. Let us assume this potential energy at this position is 15 joule. At this position 20 joule. But at this position potential energy is 15 joule. Then where does 5 joule go? Then my dear, since body is moving here, so this 5 joule energy is converted into kinetic energy. Okay. Here at the top, kinetic energy is zero because body is at rest. But here at this position, you see that body is moving. So it will have some kinetic energy here. So kinetic energy at this position of this body will be 5 joule. You can see at both the positions, total energy is constant. At the top, total energy is what? 20 plus 0, that means 20.
Yeah, 20. Yeah.
And at this position also, in the second position also, total energy will be 20 joule because total energy remains conserved. Okay.
Yeah.
Now let us assume one more position. This body is since falling. Let us assume this body has reached at this position. Now, for this body at this position, the distance is very less. Let us assume this distance is x. Let us assume this distance is x. Now, for this distance, potential energy will be very less. Okay. So let us assume here the potential energy of this body is 10 joule. So where does 10 joule go? Then 10 joule is converted
10 kinetic energy.
Kinetic energy. Because, my dear, you have also seen that when a body is falling downwards, then its velocity will increases from point to point. From point to point, velocity will increase. When velocity increase, then automatically kinetic energy increase. The formula for kinetic energy is half mv square. As you know that half mv square. Okay, this kinetic energy is directly proportional to mass and velocity. If mass is constant, then directly proportional to velocity. If velocity is increased, kinetic energy will increase. Now let's take one more position. Now body will hit the ground. Now this body will hit the ground. Let us assume body is about to hit the ground. About to hit. Okay. When it is about to hit the ground, then at this position, potential energy will be 0.
Yeah.
Almost it has touched the ground. Almost. Okay. Then the potential energy of this body at this position will be 0 because height is 0. Okay. Then kinetic energy will be
20.
Energy will be 20 joule.
20. Yeah.
Right. 20 joule.
Yeah.
Okay.
Yeah.
Okay. Here at every position, as you see that total energy is 20 joule. Here also total energy is 20 joule. At every position, the total energy is 20 joule.
Yeah.
That means total energy is conserved. Here potential energy is converted into kinetic energy. Means one energy is transformed into other forms of energy. Okay, so this is the conservation of energy. Okay, now you will have a confusion about this concept. Sir, this is the mechanics part. Then why we study it in the thermodynamics? You will have a confusion at this position. So now see, obviously this is the mechanics part, obviously, but in thermodynamics, here one more concept is here. If I have told you that here, when the body is about to touch the ground, then potential energy will be 0 and kinetic energy will be 20 maximum. Okay. Initially, I have told you that the balloon has some substance, some heavier substance, and its initial temperature is, let us assume, Ti. Initial temperature Ti. Now the question will be asked: if this balloon is touched the ground, if this balloon is being if ground is being impacted by this balloon, then what will happen? Now listen dear, since this balloon is when about to touch the ground, it will have maximum kinetic energy. And when this impact on the ground, then this high kinetic energy is converted into heat energy. Converted into heat energy. Why? Because the balloon hits the ground, then the whole kinetic energy, will be converted to heat energy due to friction, between balloon and ground, okay. So this maximum kinetic energy is being converted to heat energy, and when this 20 joule energy is converted to heat energy, then what will happen? The temperature of the working substance which is inside the balloon will increase, because 20 joule kinetic energy is converted into heat energy.
Yeah.
Then the temperature of the substance which is inside the balloon will be increased. Then here one question arises. I have seen one question in your tutorials about from this concept. I have seen one question on your tutorial. Okay. Later I will solve that questions. Okay. So this heat energy, by this heat energy, temperature will rises, and we solve this question. We solve by this formula, Q is equal to mc delta T. By this formula, we can easily solve this concept by what amount the temperature of substance rises. Delta T means final temperature minus initial temperature.
Yeah, change in temperature.
Yes, change in temperature. Okay. From here, we can easily calculate final temperature. How? This 20 joule is your Q. Okay. So putting the value of Q here, we can easily calculate TF, final temperature of the substance. So this is your energy transformation. Okay. So energy transformation is also involved in thermodynamics. So
yeah.
What you have learned? You have learned about thermodynamics. Thermodynamics is the science of energy transfer and energy transformation. Now I will give you a technical example of this energy transformation. Technical example of energy transformation. As I have given you the example of energy transfer, the example of energy transfer device is turbine, compressor, condenser, heat exchanger. These all devices are energy transfer device. And what is the example of energy transformation device? So the example for this device is nozzle. Very important example, nozzle.
Okay.
Nozzle or diffuser. These devices are called energy transformation device. Why? Because in this device there is no energy transfer, only energy is transformed.
Okay.
Energy is transformed. I will tell about separately about nozzle and diffuser in the first law of thermodynamics. Okay. Or you have learned about nozzle. In the nozzle, pressure energy decreases and kinetic energy increases. Pressure energy decreases and kinetic energy increases. As you have seen in the garage or somewhere else, in a pipe, at the end of pipe a nozzle is fitted. Okay. I hope at the where bike is washed, at that place you have seen that in the end of pipe a nozzle is fitted, and from that water at high velocity is coming out.
Yeah.
Then nozzle the function of nozzle is to increase the velocity, at the expense of pressure energy. Pressure will decrease and velocity will increase. Okay, but in diffuser, what is the function of diffuser? Reverse of nozzle.
Okay.
That means in the diffuser, kinetic energy will decrease and pressure energy will increase. That means velocity will decrease and pressure will increase. Here you can see that one energy is transformed into other form. In diffuser, kinetic energy decreases, and by what amount it decreases, same amount pressure energy increases. Energy is transformed here in nozzle and diffuser. Okay, so these devices are energy transformation devices. Here no energy transfer takes place, only energy is transformed. One energy is transformed into other energy. So these devices are energy transformation device. Now my dear, I have written a sentence previously. Let us see. I have written a sentence and I want to tell you about that. Here I have written, thermodynamics is the study of energy transfer and energy transformation and its effect on properties. What is the meaning of its effect on properties? Let us see. Okay, the meaning of its effect on properties. Okay, now my dear, let us assume the example of our human body. This is our human body. If assume we are taking heat, as food, from food, 100 joule, and some heat will go waste. Some heat is wasted. Let us assume this heat is 30 joule. Then 70 joule is stored in our body. 70 joule is stored in our body. Okay. If we do not do any work, then what will happen? From this stored energy, I can easily gain fat. Okay. And if we are doing more work, then we can easily lose fat. This means that our properties of body is changing here. If we do work, then our body will get thinner. But when we do not do any work, then we become more fat. That means our properties is changing here. Properties means if we become fat, our volume will be changed, or if we get thin, then also our volume of body will change. Okay, that means our volume will change. Our internal energy will also get changed. Our internal energy will also get changed. Then we can easily say that our properties are changed due to this. Okay, so this is the effect on properties. So my dear, this is the daily life example. Now I am giving a technical example of this. Let us see, my dear. Let us see a piston cylinder arrangement here. I am giving a piston cylinder arrangement. Piston is at this position at any time. At any time, piston is at this position. Let us assume T is equal to 0. T is equal to 0 time. At T is equal to 0 time, piston is at this position. And here, any working substance is placed. Any working substance is placed here. Now, my dear, if we give the heat, to this system, then what will happen? Then the piston expand.
It will move, yeah, it'll go.
We give the heat to this substance, this piston expand. Let us assume after some time, piston is at this position. Let us assume after some time, piston is at this position. Okay. T is equal to T1. At T is equal to T1 time, piston is at this position. Okay. Now, what you will see, initially the working substance is here. The working substance is here. But when the piston is at this position, okay, when the piston is at this position, now working substance will cover to the whole volume. Now the working substance is in the whole volume.
Yeah.
Then you can see that here volume change. Volume is changed. Initially volume is less. Now volume is larger. Also, my dear, here we give the heat input to the system. Then temperature also change. My dear. Okay. Now tell me, here the piston is expanding. Then what is the pressure?
And pressure is also increasing.
Pressure is also changing. That means pressure decreases here because it is expanding.
Oh yeah, I mean compressing it.
Expanding means pressure will decrease here.
Decrease.
Then we can say that pressure also change. What you see? You see here, by giving the heat to the system, here volume change, temperature change, pressure change. These are the properties. So here the properties are changed. So this is the effect on properties of the system. So in thermodynamics, if we supply heat energy to any system, then its properties are changed. Then the properties of the system are changed. Okay, my dear. So this is your basically energy transformation concept. Okay. In the energy transformation concept, I have told you about potential energy. What is potential energy? Kinetic energy. Okay. And what are the example of energy transformation device? Nozzle and diffuser. If anybody asks you, tell me the example of energy transfer device. Then tell the energy transfer devices are basically turbine, compressor, condenser. Dear friend, देखिए, in the whole world, there are basically two types of device. One is energy transfer device, other is energy transformation device. Okay. In the energy transfer device, there will be no energy transformation. Listen carefully. In the energy transfer device, there will be no energy transformation. Okay. But in the energy transformation, there will be energy transfer. There can be energy transfer. There can be. Here, as you see in the nozzle and diffuser, there can be here energy transfer. Okay. but basically here is the transformation of one energy into other forms of energy.
Okay.
So remember always, there are only two types of devices in this world. One is energy transfer device and other is energy transformation device. Okay. Now let's revise all the concept that I have given to you in this session. Okay. From starting, I have told you about thermodynamics. Okay. Thermodynamics is basically, this is made up of two words, therm and dynamics.
Yeah.
Therm means heat. Is disorganized form of energy. Why it is disorganized form of energy? Because it cannot be completely converted into work.
Yeah.
Okay. And I have given you one example of this. Okay. And what is dynamics? Dynamics means work. Dynamics means body is having some power. That means work transfer will occurs there, and work is called organized form of energy. Okay. That means work can be completely converted into heat. Okay. And how work can be completely converted into heat, that was explained by me from this throttling device. Okay. I will teach you about throttling device later on. Okay. Now after that, I have told you thermodynamics is basically, it is the study of energy transfer and energy transformation and its effect on properties. When there is energy transfer and energy transformation, there will obviously properties changed. Their properties will obviously changed. Okay. And why we study thermodynamics? Because our main aim is to convert heat into work in an efficient manner. More efficiently we have to achieve. We will have to achieve more efficiency. Okay. So that more heat is converted into work. We want in everything, we want that more heat should be converted into work. Okay. Now after that, I have told you about energy transfer. The energy transfer are of two types. One is heat transfer, other is work transfer. Heat transfer is associated with temperature change, but work transfer is not associated with temperature change. If you see anywhere there is a energy transfer, but this is not due to temperature change, then that energy transfer is called work transfer. Okay. And after that I have told you about energy transformation and energy transfer separately. Okay. And I hope all the concepts are clear to you. Okay. All the concepts are clear.
They are.
Okay. So then for today's session, I hope this is more than enough for you.
It's good.
So from the next session, we will start about system. We will start about system. What is system? What is surrounding? For today's topic, for today's session, this session is basically what is thermodynamics, why we study thermodynamics, what is energy transfer, what is energy transformation. So every concept which is very important, I have told you, and I hope you will have learned this concept. Okay. So my dear, this so for today this is enough. Okay. So from next week I will start from the system onwards. Okay. And I will share this PDF to you. Okay. This PDF.
Thanks.
This PDF I will share to you via mail. Okay.
Okay.
So thank you, my dear.
Okay, thank you.
Thank you. Okay, thank you.